Hey folks, I promised you a couple videos on limits, so let's do that. Here's the first question that I would have done with you in the tutorial on Tuesday, and you can see we're being asked to find the limit of a function where the value of the function, is equal to -5. And kind of the reason we're being asked to do that is if we put -5 into the function, in the denominator we're going to get 0, which we can't have. And if you think about the limit and the function for a minute, the reason, it's not so coincidental that we're being asked to find the limit where the function is undefined. The function goes along its merry way, whatever it looks like. This one's not actually that complicated. And it's defined everywhere except where x equals -5. But because it's just got that one little infinitesimally small gap, it's reasonable to say, how does the function behave around that point? Because we might need to have a function that's defined everywhere, or an approximation of that function that we can use when we're dealing with it. So anyway, that was a little more confusing than I had hoped, not so motivating. But anyway, that's why we're always being asked to find the limit at the spot where it's the hardest. So what can we do with this? I'm writing the limit every time until I actually do the substitution. You should be careful to do that too. We notice the numerator can be factored, which is why you spent a lot of time a couple years ago learning how to factor. So 15, it's probably 3 and 5. One of them is negative, and it's got to be the 3 that's negative because the 2 is positive. There, that was my lightning fast review on how to factor binomials. We could check our work. X squared plus 5x minus 3x, that will give us 2x as we need, and -3 times +5 gives us -15. So we're correct. And we also have another kind of hint that we're correct because one of our factors is the same as the denominator. And if you, this might not be true when you're working on a real math problem in the real world, but in a course like this, you can be pretty sure that this is the technique you're being asked to practice, so it's going to factor out. So the limit of that original function is equivalent to the limit of x minus 3. So we can substitute in at this point for the for the x, we have -5 minus 3. I'm dropping the limit qualifier because we've actually done the limit now, and our final answer is -8. That wasn't so bad. Let's try another one. Exact same situation here. We've got x going to 4, which is where the function is undefined. 4 gives us a negative or 0 in the denominator, so we can't go ahead and just figure out what the limit is at that point. There is a technique for this, which is why you get to practice it. We've got this square root in the denominator, which is kind of a pain. It would actually be less of a problem for us if it was in the numerator. And also we'd like to be able to manipulate this somewhat so we can see if we can factor. So what we do is we multiply top and bottom by almost exactly the same thing as we have in the denominator. The difference is, instead of a negative sign, we switch it to a positive. And if it was a positive, we would switch it to a negative. It's the conjugate. And we can do that as long as we do the same thing to the top. When you have an expression, you can multiply top and bottom by the same thing, and it is valid because the ratio of your expression stays the same, the top and the bottom. So I'm not going to factor out or expand this on the top yet. I'm kind of hoping we don't have to, because I don't feel good about my odds of doing it without a mistake right now. But on the bottom we have to, and it's easier because we designed it this way. First we've got the 5 and the 5, that's easy. Now we've got a negative root x squared plus 9 times 5. But we've also got a positive x squared plus 9 times 5. So I'm not even going to bother writing them out because they're going to cancel each other out. There's going to be a 5 square root x plus 9, and then there's going to be a negative of exactly the same thing. So instead, I'm going to skip to the second, those last two terms. There's a negative and a positive, so it's going to be negative. And I've got the root of x squared plus 9 multiplied by itself, so it's just x squared plus 9. Oh, shoot. Here I was trying to be so good, and I forgot to write the limit. Learn from my mistakes. Don't do that. And are we done? No. We've still got 25 minus 25 in the denominator, which is going to be 0. So we have to find something else to do, and we haven't taken the limit yet. Don't forget, Kirsten. But I do see something we can do in the denominator. We've got a 25 minus 9, so let's go ahead and write that as 16 minus x squared. And now we have a difference of squares. 16 is 4 squared and x squared, and they're subtracted, so it's a difference. So we know how to factor that. The difference of squares, you take the two things that are squares. One of them's a positive, one of them's a negative. You're done. And isn't that nice? We have a 4 minus x on the top. X squared plus 9. So we can cancel the 4 minus x on the top in the numerator and the 4 minus x in the denominator, leaving us with the limit as x goes to 4 of 5 plus the root of x squared plus 9 over 4 plus x. So now we can actually do the substitution. We're going to have 4 plus 4 in the denominator, which is 8, not 0, so we can do that. So now I drop the limit qualifier. 4 squared plus 9. So that's 10 over 8, which we always simplify, of course, is 5 over 4. There. That's that too. See you soon.